So let's stick on with the nature issues. So nature for us Finns, it's something that we're really proud about, and it's something that it's really thing that we are known of all the forests and lakes and the air so fresh to breathe. And as Markus mentioned, we're going to talk about air quality next. It is a question that should be researched also here in Finland, even though we are known for our fresh air. Maybe not last week when we were all drowning in the road dust, but anyway. So yeah, especially in the most crowded areas here in Helsinki, sometimes the air quality can get alarmingly bad also in here. So it's really thing that should be researched. And so next we will talk about with Mona. So what things affect the air quality and what does urban planning to do with air quality? Welcome, Mona Kurppa.
Thank you.
So you are part of a urban meteorology research group in the University of Helsinki that studies the impact of urban planning solutions on air quality. So why is researching and modeling air quality so important?
Well, first of all, over half of the world's population lives nowadays in cities, and the number is about to increase in the future. And in cities, we are exposed to different environmental factors like heat, stress, noise, but most importantly, air quality. And air pollution has many detrimental health effects. It causes these cardiovascular and respiratory diseases and leads to premature death. And last year, or 2016, it was estimated that 4 million people in the world died prematurely because of air pollution. And of that, over 10% in Europe. So it's not only a problem of China and India, but also here in Europe.
Yeah, that's what I would think when I think about air pollution. So it's quite striking that it's also a problem here in Finland and in Europe.
And also when you think about that, it's like the second biggest cause for premature death after tobacco. I think that many people don't realize it.
Yeah. So you have been using quite a unique modeling tool in your research. So what is this tool called and how does it work?
So in our urban meteorology research group, we use a computational fluid dynamics method called a large eddy simulation, or LES. So with LES, we can solve the three-dimensional turbulent field of wind, and that way also the dispersion of air pollutants. I actually have a
video about that, so you can all see how it looks.
Yes.
There it is.
So here in this animation, there's a large eddy simulation animation about wind speed over Central Helsinki under specific meteorological conditions. So for example, you can see the tallest building there is a hotel tower in the center of Helsinki, and the colors from blue to red tells you the wind speed. So wind speed, of course, is stronger when you go higher up, but when you get close to the buildings, it starts to get very complex, and we talk a lot about turbulence, so it's very turbulent. And then air pollutants are transported with that wind, so it means that also the air pollutant concentration fields are very complex, and that's something that current air quality models cannot resolve. So this method that we're using is actually the best in the world for this purpose.
Yeah, it looks very beautiful and visual, actually.
Yeah.
So how have you applied this so far? What have you learned?
Well, for example, we are actually measuring urban climate on the rooftop of Hotel Torni. So we did one study where we researched that when we measure on the rooftop, what are we actually measuring? Where do the air masses come from? Do we measure air masses coming from the sea, or is it the air masses from the city? And the other one that has gained quite a lot of publicity was a study about these city boulevards that are planned to be built in Helsinki. So we did a study on Hämeenlinnaväylä, where they were planning to build a city boulevard. I don't know the current situation now, but still, we were studying that if we would build a city boulevard there, how should we build the neighborhood in order to make it as good as possible for air quality and make the air ventilate so that all the traffic emissions near the ground would be transported away from the air that people are breathing. And there we could see that the best solution would be that along the city boulevard, where all, like most of the emissions will be, it would be good to have short street canyons and also have some alternation in the building height, so to make it like very complex in nature, and that why make the wind field also more turbulent and increase the transport of air pollutants there.
Yeah. That's really interesting. I bet you have many other plans also for using this model in the future also.
Well, actually, my PhD project, or most of it, is about applying air quality component to this LES model. So what I've been doing is that I have implemented an aerosol model to this LES, and then a group in Germany has implemented chemistry model for the chemical components, such as nitrogen dioxide and ozone. So currently the model is capable of modeling the real air quality in cities, including the aerosol processes and gaseous reactions. What else did I want to say? Yes, so what is the goal of developing this kind of model is to, of course, then we can further broaden our research, or the research questions that we can have. For example, when you think about trees in urban areas, usually people think that trees are good for air quality. But actually, trees are not always good for air quality, since trees block the flow and decelerate the airflow, and that way the dispersion of air pollutants is also decreased. So when you think about, for example, street canyon, and then you have rows of trees there, they block the flow, and that way, if you have emissions from traffic, the emissions cannot escape the street canyon as well as without the trees, and that way trees decrease air quality. But then on the other hand, you can have deposition of air pollutants or aerosols and gaseous compounds on tree leaves. So when we include all this aerosol physics and chemistry to the fluid dynamics model, we can actually compare these two effects, the positive and the negative effect of trees.
Yeah, that's quite surprising, actually.
Yeah.
yeah. So, what do you think about the air quality here in Helsinki? Where are we heading at the moment, or is the city now considering a lot of this, and where do we stand at the moment?
We are actually cooperating quite a lot with the city of Helsinki concerning this new plans for building the city. So I think the city of Helsinki is very aware of the problem. But on the other hand, the problem in Helsinki is not that big as in bigger cities. But as you mentioned, for example, last week, the air quality was rather bad because of the road dust. Yeah. So I think that Helsinki is doing the best as they can. And they're investing, for example, a lot on city bikes, which is good for air quality as well.
Yeah, but I think developing this kind of model is really important, maybe because also for us, but as you said, we have the situation quite good, but to apply this to the big cities where there are lots of air pollution, the big cities in Europe and in Asia.
Yeah, of course we will apply this model here first in Helsinki, but then in other big cities.
Yeah.
Yes.
So, thank you very much for coming here today, and thank you.